Alright, so this is our clone Sierra Nevada Pale Ale that we've got fermenting right now. And just a breakdown of the setup, I guess. We've got our bung rigged up with our blow-off tube. Got a little bit of water in there, so you can, it's kind of like an airlock, I guess, but it bubbles, keeps the water in, and keeps the CO2 inside the vessel, which protects our fermentation from too much oxidation, and kind of preserves it along its way. And I've got the blow-off tube rigged up into this bucket, and right now it's not really necessary, but this foam has the potential to kind of get really crazy, so it'll completely fill up the rest of the vessel, and that's why I've got the blow-off tube. The foam will come out the blow-off tube and into the bucket, keeping it from making a gigantic mess all over my apartment. So what I do every day throughout the fermentation is I'm going to take the specific gravity reading of the beer as it ferments, and also the temperature. Monitoring these two things is pretty key in fermentation. First, the specific gravity. The numbers read kind of like this: 1.045, 1.040. That's our specific gravity. And then obviously this is our temp. The closer the number is to 0 on a specific gravity scale, well, water reads at 1.000. So obviously with the addition of the sugar from the grain, and also the hops, all the compounds that are extracted during the fermentation and during the mash and the boil, they're going to change the water. They're going to make the specific gravity go up. And then throughout our fermentation, the yeast is going to be breaking down that sugar and creating alcohol and CO2 and heat. But with the addition of alcohol to the beer, it's going to drop our specific gravity. So getting these readings is kind of scientific evidence that our fermentation is actually happening. But obviously it's going down because of the creation of CO2, which is being trapped in this bucket. So if I stuck my head in there, no oxygen, I'd die, I'd pass out. So you can see the beer is pretty active as far as sediments rising and falling. And here all the way at the bottom, this is where all the bits of grain and hops reside. And they get picked up by the CO2 floating around, brought up to the top where they kind of contribute to this foam cap, and then they drop again. A lot of movement going on. It's pretty cool. So that's the fermenter, the bung, the blow-off tube, and our little blow-off collection bucket. So what I've got rigged up right here, all ready to go, is a graduated cylinder with some beer in it. And you can see the CO2 bubbles sticking to the cylinder on the inside there. That's what all those little bubbles are. It's all CO2. This is the hydrometer that we use to measure the specific gravity. It's got a thermometer in it. It's got a weight. And then it's got a specific gravity scale. And like I said, the water reads at a reading of 1. So there's 1.0, which would be water. And then the higher it is on the scale, the more fermentable sugar that we have in our beverage. And then as it drops, that's a sign of the fermentable sugars dissipating. So I'm going to take this out, and I'm going to rinse it off really quickly to get off all the CO2 that's sticking to it, and I'm going to take a reading. Alright, so you take the hydrometer, place it in, and I'm going to give it a little spin. It's going to keep the CO2 from sticking to it. And take our reading. The table's not exactly level, so that's making it more difficult. It looks like it's just above 0.20. Looks like it says 1.024. Yeah, 1.024. So our gravity started out at 1.045. The next day it dropped to 1.040. And now we've got a reading of 1.024. The specific gravity with reference to the hydrometer, it does differ based on our temperature. So it's one of the reasons we take the temperature is to make sure that this reading is accurate. And then another reason we take the temperature is to make sure it doesn't get too hot. And that'll kind of stress out the yeast and it'll start to produce some off flavors and off aromas. So this came with the hydrometer. It tells you that if your temperature is at 60 degrees, your measurement is accurate as is. No need to make any correction. If we're at 70 degrees, you add 1. There's an example of adding 1. That's actually an example of adding 3. So their temperature was at 70. It was at 84. They had to add 3. So last time we were at 69.70. So I made an add of 1, and we're going to see where we're at now. I'm going to take the temperature using my thermometer that I have. I put the thermometer into the fermenter. It's got a little stopper on there so I don't lose it like I've done before. We're going to take a measurement of the temperature. Wait a couple minutes. Now you can see the bubbles a little better. It's all CO2 formed by the fermentation. When the fermentation is done, we'll obviously no longer have CO2 being created by the yeast. But once it comes time to bottle, we're going to add more sugar to the beer, and it's going to jumpstart the yeast again. But this time it's going to be trapped in the bottle. It's not going to escape out a blow tube or anything. And so instead of forming bubbles, it's going to be dissolved in solution with the beer, and that creates the carbonation. And when you open it, you release the pressure and forms the bubbles then and carbonates our beer. So that's the two important roles that CO2 plays in beer making. Byproduct from yeast, protects it from oxidation, and then gives us our carbonation when we drink it, and it's delicious. Alright. Temperature is 72. 72. So with 70, it says to add 2. So I'm going to keep it like that. 50. Actually 70, it says add 1. Yeah, okay. So, just like the thing says, we're going to add 1. And that's going to give us a total of 1.025 and 72 degrees Fahrenheit. So, obviously our fermentation is going. We're seeing a drop in our specific gravity. We're seeing a rise in the temperature. And we're seeing a creation of CO2, which is all these little bubbles. Take out the thermometer. I also give it a smell, just to make sure that the yeast aren't too stressed out. When they get stressed out, either they're not provided with enough nutrients, or the temperature gets too high. They're going to tell you. They're going to let you know by producing compounds like hydrogen sulfide, which is the rotten egg smell. But what it smells like, it smells like a nice little balance of like light hops and some grain and CO2. Smells like that. But it smells really good. It's not stinking at all. It smells like just like it does out of a glass, except the hops is a little more pungent than it would be in the glass. So everything looks really good. Beer looks good. It smells good. Fermentation's cruising, and that's it, man. That's how we do it. We're gonna wait probably about another week or so, and I think for beer to be done, you're looking at a number like 1.010. That's gonna kind of be our target, and that'll be our final gravity. This would be our original gravity, 1.045. Final gravity, 1.010. It's probably what we're gonna get. So, man, that's it. Hopefully we'll be tasting it soon, and all this will be worth it. All right.